Okay, welcome everyone. Today, I want to talk to you about an important topic being what is the difference between MLOps and ModelOps? You hear both terms out there today, and there's a lot of confusion in that space. So I'm Jim Olsen. I'm the CTO at ModelOp, and we design a from the ground up native application to actually do ModelOps and run that in your business. And I just want to talk to you generically about the different categories today and why it's actually important because there's actually an important difference between model ops and ML ops. So, everyone's kind of familiar with ML ops in this particular organization where, that's very, very targeted at machine learning and the machine learning development life cycle and solving a very important problem, which is, okay, now how do we get it, these models actually trained correctly, actually, monitored and getting a feedback loop so they can be retrained on that kind of things on that. So you get that continuous loop of basically the development, the deployment, and then the monitoring, and then feeding that information back into the development so you can retrain and redeploy and monitor. And it's a very important concept on that. And so when we see solutions that are basically targeted at ML ops on that, which is machine learning in specific, there's a lot about the development of the model, the training of the model, the hyperparameter tuning, and all those things that actually need to go on that are specific to machine learning models on that kind of things. And then ultimately, at the tail end, they absolutely have a little bit of an idea about the model, although it may not be a very holistic picture of the model, but it's capturing the information that's basically pertinent to the machine learning process on that kind of things. And then absolutely do monitor the data to see if there's a difference between, for instance, the data it was trained on versus the data it's seeing now, classical data drift, or things like concept drift, where it's making different predictions than what you would kind of expect on that. And then basically, you get some of that basic information, but it's very heavily biased towards this upfront process of the training and the retraining, and then just the monitoring on that kind of things. When we start to talk about model ops, model ops is actually everything that MLOps is plus more. There's a whole lot more there to do. So, we're not as focused on the development of the actual models themselves, but rather, all the information about the models, what makes up the models, who made the models, all of this kind of information. And basically, doing this across all kinds of models, because absolutely machine learning models are important, and they're rapidly coming to play more and more in the industry. But in the reality is, we've seen everything from just simple decision tables to graphs to traditional logistic regressions. All those kinds of things are important models that are actually making business decisions within your business, and also need to be managed along with the machine learning models, so that we get a complete picture of what is going on across the entire enterprise and organization. So, when we look at a model ops solution, it actually has a lot more moving parts to it, and they're focused primarily about post development. So, when you want a good model ops architecture, it should integrate with existing development environments. There's, rather than being a single one, like a machine learning platform such as SageMaker or things like that. Realistically, you're going to have to work with things like Jupyter and R and Dataiku and all kinds of things, even down to just simple entries within the GitHub repository on that kind of things, on that thing. So you're going to have to work across all of those different model factories on that kind of things. And then when we actually get into managing the process, because the process is going to be a much longer running process, we're going to need to integrate with the existing IT infrastructure to actually kind of deliver those services. So rather than being specific to the data scientist and providing tools and information just to them, you're going to have to integrate with things such as ticketing systems or security scans and Jenkins systems and authentication systems such as Ping Federate and other kinds of things, in order to holistically provide the information across the entire enterprise for all of these different kinds of things like that, as well as likewise where they end end up getting deployed, you're not going to likely deploy the same machine learning model onto the same runtime as something that's making a simple decision with a decision table. They're going to have very different requirements. So how do we make sure we orchestrate getting those models out to the appropriate runtime place where they actually do that? So, really a ModelOps solution you can think of as being that conductor of the orchestra across all the different moving parts, all the different models, all the different assets that you're actually going to need to bring together to not only facilitate the movement of the models out to the production environment, but also continuing to assure things such as regulatory compliance and auditing, and that you've done the required steps and all of those different kinds of things. And so a model ops solution is really MLOps plus a whole lot more, and working across all those different models. So, again, I mean, I already kind of mentioned this idea of bringing all the different players together, because you're definitely going to have the data scientists working within their model factories and tools and automated retraining and things like that going on there. But you're also going to need to know, well, where was the data coming from? What kind of, how do we notify people that things are wrong? How do we ensure that something was done about to solve the problem that we've detected? It's one thing to monitor a model and determine something's go wrong. It's another thing to make sure that there is a timely resolution, as well as we get into things like model risk management and visualizations and bringing those together and sharing information across the business. So it really is a very large space. The kind of things why we need a solution like this is we need to look across all those different models across the entire organization, and understand in a consistent manner, no matter what the implementation of that model is, whether it be machine learning or whether it be an R model or a simple decision table. We need to have common language, a single pane of glass across to provide answers to the kinds of questions we need to know, like how many models do we have out there? When were they approved? What kind of decisions are they making? Are the decisions good? What kind of an investment do we put into the model, and what kind of investment are we getting out of it? So some very business related questions, as well as to just mathematical or statistical related information on that kind of things. And again, getting into the idea of are the compliance and the regulatory requirements being met on that kind of thing. So a model op solution needs to answer a lot more than just the math behind the model and how it's performing, but these business requirements and needs as well. And how that's actually done is we refer to that within our product as the model lifecycle, being the complete model lifecycle. The MLOps lifecycle is a very tight integrated loop for basically managing that retraining and detecting, and when does the model need to be retrained, et cetera, kind of a process. And it is a much smaller process. And we refer to that more as the model development lifecycle, and the natural kind of feedback loop you get there. But when we get into actually trying to provide a complete model ops level model lifecycle, really these processes span, hours, days, months, and that kind of things to provide that kind of complete auditability of what the model has been through in order to actually get out and make predictions. So, you're looking at things like completeness analysis, and we'll go into that one in more depth. But like, are all the pieces of the model there, so we know what's in it and where it's done? Has it been through security scans to make sure it's actually not using libraries that have known vulnerabilities? Do we have documentation associated with the model that may be required? Things like the Frank-Dodd Act actually require very specific reports before a model is used within the business to make those kinds of things. And as well as doing things like making sure the model works okay. Is it stable? Does it crash? Can it handle bad data gracefully? That kind of things, as well as likely the type feedback loop of a traditional MLOps solution doesn't take into great account the idea of like promoting the model through different stages, where you may just want to have it in the dev environment first, see how it performs, but then you want to actually maybe run it in parallel for X number of days, weeks, or whatever before you do move into promotion. And how do you manage that and ensure that the model is ready for promotion from those environments, and ensure that happens in a timely manner, as well as traditional monitoring that MLOps absolutely does. That's absolutely a requirement and important there. But also, one of the things taken into account is at some point a model needs to be retired, and managing that full process, making sure, okay, is there another model ready to take its place? Have we started development of that model because this other model is nearing a point where we feel it needs to be retired? Well, how do we make sure that the data scientists are aware of this and can actually go out and do that and be ahead of the game, so not scrambling at the end to try to come up with a replacement for these ones that are maybe going out of that, as well as managing those integrations with the IT environment. So, traditionally things like, for instance, code analysis and things like that are done within Jenkins. You probably may already have existing DevOps implementations that provide this. So the model lifecycle needs to actually integrate with that, use those existing assets, and actually kick those off and track and associate with it to prove that those things have been done, and associate those results directly with that version of the model and that kind of things, as well as different alerting and ticketing and things like that, and then centralizing all of the reports so you can share them across the business, and you need that model lifecycle. So this here is an example of a complete model lifecycle of what it would look like realistically within a business. As you see, it's quite an eye chart. And don't worry, we don't expect you to read that. What we're going to do is look at a few key areas of this to give you an example of what those kinds of things might be doing. So for instance, we refer to a version of a model as a snapshot of a model. It's something that's immutable because basically once it's been tested, approved, et cetera, and you move it towards deployment, you want the auditability of saying this is the exact model that was used to make that. So we refer to that as a snapshot of the model. But so one section of that larger graph there is all about basically kind of like some simple validation on making sure the model is ready to even start the process of being validated and kind of put into test environments and things like that. So for this simple example here, what we do is we do assure a few different stages here before we basically waste anyone's time looking at a model that may not have all the pieces. And we may need to get back to the data scientists and say, hey, we need to add some additional info about this model before we're ready to move it to things. So a first test of that can just be completeness. So is all the information necessary to monitor that model provided? So for instance, do we have a link to the original training data? Do we have information about where new data will be coming in so that we can go out and look at it? What kind of what do we expect the acceptable limits to be? And that should be on a per model basis in a good model ops architecture. We want to ensure, because every model is going to have different levels of different metrics and how you compare them, false positive versus false negative versus whatever. You need to take all those into account, and every model, depending on their usage, is probably going to have a different set of criteria for that. So we need to know that kind of information that's there. And then we also want to make sure it has the appropriate documentation about, any analysis of the data itself, or, steps that were taken about creating the training data set, et cetera, that may be, again, required for specific regulatory, or perhaps even just for your own internal purposes, so that you can have some rationale behind that model as well as to what has been going on there. And then once we assure that all of those items are present, then we want to actually go out and do some simple security and vulnerability tests. And traditionally is that we choose to launch those through Jenkins, although you could do a direct analysis and run that there locally within a solution as well. But basically, we want to make sure that it meets the enterprise level standards of compliance. So for instance, things like using Veracode to actually scan through the actual source code and libraries used to find any known vulnerabilities, and be able to create tickets to say, hey, we found this, you need to upgrade to this library before we're going to promote it beyond here. And we can actually do that and create like a Jira ticket back to the data scientist to say, please fix this, and then rerun it through that process and actually manage that whole kind of a flow there and that kind of things. And then we can, have the assurance that we know that there's some quality behind that model as well, and that kind of things. Then finally, again, if we're going to promote this model through, another good example of the next step we take to ensure that we're ready to start the promotion of this model is that we take a simple test job using some smoke test data that the data scientist provides, and actually put it on one of the target runtimes that it plans to go to eventually, a kind of a test environment. It actually just run a simple test against that test data to make sure we get some reasonable expected results out of it, and that there isn't a glitch, that maybe there was a missing library or something that wasn't specified, et cetera, as well, so that we have that, and that it can handle that kind of test data. So just through this process, this is a very small first step of the process, we've done an awful lot to basically ensure the quality behind this model before we spend a bunch of time looping back, and we can create a tight loop in the beginning to get information back to the data scientist immediately through a ticketing system if in fact something has basically is amiss with the model they just submitted, kind of like unit tests in the DevOps world for source code for traditional programming. So this provides that kind of a level. Another example, we'll look at the other extreme rather than the very beginning. We'll look at the very end. Is we feel that MLOps solutions absolutely offer some monitoring of the model of a variety of types on that kind of things. About kind of real time is like what's going on with that. But what we feel that a ModelOps solution also needs to provide is to also make it actionable in nature and make sure the resolution occurs. Because if we see that a model perhaps needs examination because let's just say there's simple data drift beyond specific thresholds to that model, then we want to make sure this actually gets looked into and more importantly resolved in some sort of a way. So rather than just sending out an alert that may end up going to a random person within the enterprise who may not know anything about this model, we can actually take a ModelOps solution actually should basically kind of shepherd it through making sure there's a resolution too. So for instance, we can look at that, actually run one of these monitors and that kind of things, compare the results against the model specific thresholds defined within the model that we saw being checked earlier in the last slide, and then actually creating a ticket out in a ticketing system like Jira, ServiceNow, or those kinds of things, where then we can track the actual progress of the resolution of this, so that we can start to promote up a replacement category or kick off an automated retraining if that's what is appropriate, or those kinds of things, and then understand that that action ties back to this original model and closes that loop and brings that up to be replaced, and then actually we know then that this other model can then be retired, and we have that kind of basically ability to do that. Now a good model ops solution will provide out of the box monitors that provide for this, but will also allow flexibility in allowing you to create your own monitors as well, because you may have business KPIs that you want to make sure are adhered to as well, beyond just the simple traditional basically kind of statistical approaches to things like p-values and things like that. And in the long run, this it really increases the value of your models and closes that loop quicker, because you make sure there's a resolution, and that the issue has been resolved, or either by just saying, yeah, that's actually performing okay even with this new data, but or you have that replacement actually put into place. Because really what we're trying to get to is basically if you have, especially with machine learning models and things like that out there, they are vulnerable to data drift and all these other kinds of things, and you want to make sure that you're always have shepherding that whole pipeline going along, and you understand that risk exposure that's out there, and that you can do this for the thousands and thousands of models that are going to end up within your pipeline in the long run, never mind the interactions and interplay between if you have a model depending on the model and those kinds of things as well. Because where we want to get to is we first need to know what we have out there, and MLOps solutions provide some level of that, but it's very specific to machine learning models. We need to actually understand all of the models in production. For instance, you may have a simple model that does data transformation to feed into a machine learning model, or one that does data augmentation, that kind of thing. That's still part of the model, and you need to make sure that that one's up to date, and that that those things stay lockstep together on that kind of things. And then also, who is using them out there? Because once you create some of these models, they can be used in a large variety of places. So you need to do that, and then you need to make sure that, again, that those models are properly retired over time, so that if you detect a problem in one use case, all the other use cases are taken care of as well. As well as we need to look into the models and see what's actually there. Have we done the appropriate bias tests and et cetera, and things like that, to ensure that they're not making basically predictions that could put us at risk in the long run. Because we want to make sure that it's like they're accurate, they're fair, and they constantly have that feedback loop to improve the model over time, so that they don't become stale. And to do that, we really need to look across our entire portfolio of models within an enterprise to actually be able to understand, what is our risk? Because let's be realistic, it's a progress, it's a journey that we all have to go through, and we want to reduce that risk over time, but we need to understand where we start. As basically, where are we right now, and how are we doing? How are we doing at closing out these issues, and how quick can we bring them together? How many models do we even have, and which ones are vulnerable, and which ones may have not the attention they need on that kind of thing. So you need to actually share these kinds of reports across the entire enterprise, and they are not only statistically kind of significant in reporting those kinds of issues about like excuse me, non-business related issues, but they also need to be very business specific. What is the impact to your business? What's it costing you? How are you doing that? So in order to do that, a good model ops solution will integrate with existing kind of standard reporting tools, such as things like Tableau and Power BI, et cetera. So you can share those reports across the enterprise and customize them to your business. So you want standard out of the box ones that report very industry standard ones, but likewise, you're going to want to rebrand those and kind of basically customize those to your specific business as well. And why do we want to do all this? Well, the Federal Trade Commission and the EU have recently released some very specific guidelines and reports around basically machine learning models in specific, that kind of things, but they really do apply to traditional models too. And I'm just going to share this particular quote with you because it shows the importance of why you need to get a handle on all this data and what's going on with your model. As we've noted, it's important to hold yourself accountable for the algorithm's performance. Our recommendations for transparency and independence can help you do just that. But keep in mind that if you don't hold yourself accountable, the FTC may do it for you. And I, for one, don't really want the FTC holding me accountable because that, it can be very large fines and stuff like that. So the goal of a model ops solution has to be to provide that information and transparency that you're doing the best possible effort you can to hold yourself accountable. So if there are any issues and the FTC or the EU come to you, you have that kind of traceability and accountability and lineage that you can bring to them to show the rigor you went through to hold yourself accountable so that the FTC and the EU don't do it for you. So with that, I want to thank you for spending the time today to hear more about ModelOps solutions, and I encourage you to visit us as well at modelop.com to learn more about our solution in the ModelOps space and what it can do for your business. So again, thank you very much.